Recording is on. Yes, we're ready to go. Well, hello and welcome to the third part of the series, Good Designs, Good Business. Our focused session over these last three sessions has been on Java refactoring and designing for testability. Part 3 today discusses end-to-end testing of applications. And once again, I'd like to reintroduce my friend and speaker, Ken Britton, programmer analyst at Computer Sciences Corporation. With that, Ken, let me go ahead and flip the slide and transfer control over to you. And welcome again.
Hey, again, thanks for having me. Today we're talking about end-to-end testing, which is, at least for the projects that I'm on, a variation of unit testing. Whereas unit testing with JUnit, you're testing your code, you're testing individual objects, methods, things of that sort. But we still need to have a comprehensive solution to test the application itself. I don't think it's reasonable to rely upon a QA department to test everything that a developer or the project is going to be doing and or accomplishing. Quality for a particular solution rests upon the developers developing it, and we need an end-to-end solution to test that in an integrated environment. So one of the things we need to talk about is what are the goals? Everybody can talk about quality. We write unit tests to prove that our code is good, and that gets us most of the way there. But in a corporate environment where you have clients, in a contract-type relationship, there needs to be some sort of deliverable. If we were in a software development house developing shrink-wrap software or applications that we used ourselves, I think it would be enough to write your unit tests. You have the relationship with the testers, so you can build up a rapport over time, and say, oh, we have such and such coverage. We've taken this into account, and everything is right in line with the expectations, and they can take that and run with it. But when you're dealing with contracts and clients, they need a little more than the proverbial handshake in that it's been done. They're paying money for a specific deliverable, and the deliverable needs to be demonstrated that it has been complete. And in our environment, we use end-to-end testing. We have an entire department that documents and records all of the various projects so that they can review them with the client at the end of a project to ensure that everything, all the requirements being met. And we still do end-user acceptance testing and all of that, but the demonstration of what we're doing it needs to be established. So, we have a series of goals that we need to hit, and one of them is, we have a department for system integration testing. I said they're the ones who are handling. They're the ones who are going to be handling the interaction with the client for the final deliverable, demonstrating that the particular project in question was coded and tested in a fashion that is suitable for the client's needs. We don't want to obviously throw out anything that's inferior in quality, so you have your unit tests. The developers are ensuring that quality, but the other team who are not developers but testers are now responsible for documenting the results of what the project meant to accomplish. And those results, in our particular case, is actual documentation, not documentation in the form of books, manuals, things like that, although the product has that. It's more of a demonstration of the functionality and getting the client to sign off on that, because obviously, in a contract relationship, that's how everybody's getting paid in the end. So our test goals are to do that. And on my team, one of the problems that we ran across was in doing unit tests. Developers like to write code, so writing a unit test is not some arduous task, but creating a document that demonstrates you did something, that's a task that's not coding. It's boring to the developer, and they really don't want to do it. So when it comes time, you finish coding a project, you're fixing an issue, you now have to demonstrate, to the other parts of the organization, including, managers with various write-offs, that the project is done. And it's enough to, for a smaller project to say, just do a demonstration. But for larger, complex projects, you have to show, this is what we did, this is how we tested it, this is how it works. For a large system with a lot of moving parts, something like that to have some artifact that you can point to is very helpful. So developers doing their unit tests, but that's not giving the other organizations within the overall company what they need to do their job. So what we came up with is a unit test library based on Selenium, and Selenium is because our application is a web browser-based or web-based application. Selenium is a library that connects to a browser and allows you to control various elements on the web page. So from a coding perspective, the developer can write a unit test that will drive the browser to accomplish a certain task, and that's good. So now our unit tests for our end-to-end regressions are not documentation at this point. We're writing code. So the developer is fully engaged. They're creating a document after the fact based upon the running of a test. They're not sitting down into a Word or other type environment and doing word processing, taking pictures, and producing a long document that, frankly, developers really don't enjoy doing. So one of the things that our library does, you can see, we have our SIT, which is our System Integration Testing Team, and they prepare all the documentation for the client, but we have them so they can be archived. It's a contract. It's with a government entity. The government entity, could be audited at various points by a federal or other state organization. So they need these artifacts to be archived in some fashion. If we gave them a piece of paper, that would be good, and you can definitely archive that. There's companies that handle it, but from a production point of view, in order to get another piece of paper, we have to create another piece of paper. And, from a developer perspective, sitting down to write documentation to be filed away is nothing that they're going to be looking forward to. So we came up with a system where we're writing test cases. We're writing with JUnit. We're using Selenium as a library to drive the web browser. So we can now have individual unit tests being driven by the RAD environment, our unit test runner, Maven for builds, and they run on a machine. They run these unit tests that drive our regression. For my project, we have 2 developers per project minimum. That means for no matter what size the project is, if it has a UI component to it, that particular project must have 2 developers assigned to it. One developer is in charge of creating the actual project, fixing something, adding functionality, whatever the client has requested. The other developer is writing the regression at that point for the first developer. So we have our JUnit for code quality, and we have our end-to-end test for the requirement quality, meaning, the web page does what it's supposed to do or it functions in a certain way. So these developers work together as a team. And it's not the same amount of coding per developer, depending upon the project. The end-to-end regression, more experienced developer can actually take and code that regression in about 25% of the time it should take to do the entire project. And that's a scheduling number that we use, unless the project is particularly complex, and we can always give more time. But it's about 25% for the second developer to get the actual unit test regression coded. Now, they're just standard. They're written as standard unit tests run by JUnit in a standard unit test runner. They use Selenium, and one of the things that we strive for is we're producing the documentation for the client at this point. So like I said, we have a custom library that takes screenshots at various stages at the developer's direction to demonstrate that the functionality being tested is happening. The look and feel of the screens are the way they're supposed to be, and those screenshots will be saved for later when we can generate our actual documentation. We call that that process is producing a test package. The test package is the demonstration. By switching to a system where we use code to create those test packages rather than allowing we use code to create the packages rather than having the developer write the documentation. So our documentation is better at this point because the developer is fully engaged. There is no sitting down at a Word document taking screenshots anymore. We're writing code, and we're trying to get a result from the code. Another added benefit that we particularly enjoy is that the code can be run again. Previous to my involvement and developers were creating singular documents that were handed off, it was just that, a singular document, a point in time for a particular project. In order to recreate that document or recreate that documentation, you had to do it all over again. Now that we have unit tests, and if you remember from before, our unit tests are code. They're first-class citizens in the project, same as the regressions, because there's just another variant of our unit tests. They're all first-class citizens. They're maintained as code in the project. We can run them again at any time. And because of that, we do have an issue with data consistency. Anybody who's worked on a large database-driven project knows that having multiple environments or multiple databases and multiple people using those environments and databases, you don't really control the data as you think you should. So you can write a test that expects a certain amount of data or a very specific piece of data to be in the system, and that data does not necessarily have to exist at the time that the test is run the next time. So we've gone through many systems to try and control that type of data. One was more an informal, don't touch my data type scenario where the developers on a team would agree on certain key records, primary keys that they didn't want to be touched by other developers. They would, in fact, have their own little data sandbox in the database. As you can imagine, that fell down rather quickly as other people in the organization found particular uses for the data you were looking at, and you couldn't isolate the particular elements that you wanted. The end result being your unit tests, your and regression tests would fail. If you're expecting a provider ID and that provider ID suddenly doesn't have the characteristics that your test depended upon because a either a developer or a tester in another part of the organization changed it for some reason, your test would fail. And it isn't even to the point where other developers are being nefarious and going in and changing data. We do have periodic refreshes of production data to the development environment to maintain a consistency for the various table structures across all the environments. So it's just a natural progression that over time you will lose your data. So our next step was to try and figure out a way to manage that data in a consistent fashion. And our database is somewhat large, has a dedicated team of DBAs, and approaching them about creating yet another schema or database for a test environment was not something they were willing to sign up to. So in that case, we decided, well, what if we took an approach of creating, more attributes or, annotations in our library that we could then use to ensure our data quality. So we came up with a system that we created an annotation that we called data required, and you would give it a name, and that name would actually map to an XML file that contained SQL. And if we ran a test, we could figure out, based upon where we were in the test, because you were calling certain methods in the test, and using reflection, we would come up with any annotations that are currently active for the test, and we would run those elements, those SQL statements that were contained in that corresponding file. We thought we had hit it with that because it was good. But the issue turned out to be the length of time spent running tests, grew a lot, because before every single test, before any time any developer wanted to run these, they would be executing a lot of SQL. So every unit test, so if you have a class that has 10 methods, perhaps you can get all 10 to run a good portion of SQL to ensure the database is in a consistent state before you could actually run the test. And then for the next test, you would do the same kind of operation. So the length of time that it took to run our test grew dramatically, and people stopped wanting to run them. So we came up with our third and final solution, where we need to create a stable environment for our data. So what we did is, what we were testing, we created a local database using Derby that would be run on a server where we're running our tests, and the developer could run them locally on their development machine. The database was a very small subset of our overall database that was in a real development region or production environment, but it was specifically suited for the tests that we were running. So this gave us the ability now, we can have, using our library, the ability to write a unit test, end-to-end regression, rerun it at any time in the future. We would have data consistency in the environment, so the tests would run in a clean fashion, and when it was all over, we would have the documentation that we needed to demonstrate to the client what we were doing. The client acceptance criteria, was clearly defined in the requirements. So the end-to-end regression tests that we created what we call test packages. Test package is, like I said before, the demonstration that what we set out to accomplish for the project or the P-log was actually demonstrated. We accomplished it. We're not hiding anything at any point. Again, this might not happen in a software type environment where you're building software for resale, but then again, it might, depending upon the handoff procedures between your actual groups within groups. In our case, the client, originally was all for the hard copy. We started producing, soft copy that, automatically via unit tests in a repeatable fashion. And this caused, I wouldn't say some concern, but, it was something new that needed to be introduced. And, they were used to getting a large packet of documentation somebody would take and go through. And that's not to say that we couldn't, at this point, print our documentation. I'm sure some people have, but the goal is to produce it in an automatic and repeatable fashion. So we perform a build, we run our unit tests, our unit tests all pass, and then we go off and we start running our end-to-end tests to create our test packages. And the test packages at this point wind up being PDF files in a directory with a certain naming scheme based on project, based on defects, and you can then go in after the fact and take a look at that. One of the things we experimented with a lot of different ways to create that actual PDF file, that soft copy, and one that we found most flexible for us is our unit test takes screenshots of the web browser, puts it into a certain location, and then we run a script over that location which collects all of those text file or image files and creates an XML file. The XML file, based upon certain naming conventions, is then translated with XSL into a FOP so if anybody's used XSLT, there's XSLT-FO, which is formatting object. So we take our XML, we translate it into an XSL-FO file, which is then run through another process which produces the actual PDF generation. The only thing that we have as an artifact are the actual screenshots, the text from the actual unit test itself, and PDF at that point. And the generation is rather quick, and we get going. We tried a portion using screen recording because we had read something about it, and we thought maybe this would get us out of the creating the document problem. But one of the things we found out very quickly, while it's good for looking at a test run overnight, it's not good for client acceptance criteria. And you can't search it. You can't go looking through it like you can PDF. There's no pages per se. You're looking at a timeline. And while the concept was nice, we only found it helpful for debugging a bad test that ran overnight. And again, that quickly fell out of favor just because of the setup involved. So if you're doing any sort of demonstration of what product functionality is, the screen recording really didn't help us out as much as we thought it would be. So let's move on to some code and see how we accomplish what we're talking about here. Okay. So here we go with, we talked about our end-to-end tests being, first-class citizens in the actual project, and this class right here is kind of a demonstration of that. This example that I worked up uses developer works, but, this could be any project production environment. So the concept is called page objects, and we're creating a mapping, abstracting out a web page to a class. Not everything that's on the page, and you can see if we go to the developer works page. So for every page that we want to test in our end-to-end regression unit test system, we need to create a corresponding page object within our unit tests. This page object defines various elements on it that we want to use in running the test. The other thing that this page does is expose functionality that is required in the application or provided for by the application, so that the developer of the unit test doesn't have to write a lot of repeating type page manipulation code by hand. So when using this product, you can see we have, go to Developer Works page, well, I'll leave that. So if you go to the Developer Works page, you can see here down the search box is defined by using the Q ID or name, which is how it is on the page. So our web page object needs to define that, because at least for this particular test, we're going to use that element on the page. So we have our constructor. It takes a web driver. We're using Selenium here. Roger mentioned that there's an IBM product to do the same thing. But the concept is very similar. You have something that is going to connect you to your browser. The page object itself is obviously going to take it in the constructor so it can use it and build up various elements over time to perform the functions. We have a functionality right here called search. And if you call that, you can see we're sending our query to the search box, and then we're submitting our search, and then we're creating and returning another page, which represents the search results page. Again, every search, every page that you want to represent in a unit test needs to be represented by a corresponding page object in your object model. And then you expose various elements of the functionality that you want to perform in your test via those page objects. And that brings them into line as a first-class citizen. So if somebody goes into a page and they remove a field, that's going to break certain unit tests. That's going to break certain end-to-end tests. And all of those tests need to be modified to be brought up to speed with the latest project changes. So we go back to our page object itself, and you can see we have a page factory here. Now, this is just a library implementation, but this is where the product maps your web page to specific members of your page object. And it does the mapping by the annotations that you supply. This gets the developer themselves out of writing a unit test, so in the arrange section, you don't have to go find all of these things over and over and over again. And the other thing that we found is once we started doing it that way, before we came across this, the page object model, your actual individual unit tests would have, much like JMOC expectations, a long series of steps that would be operating on the web page. It wasn't related to the test itself, testing the particular entity, but more of a setting it up so that I can test the particular entity. And that started repeating a lot. Since we've moved to a page model, we have one particular instance of a page object that can encapsulate all of the functionality exposed by that page, and that particular object is reused across multiple tests. So it's a nice way to encapsulate various things rather than spending the time writing it over and over in each individual unit test. We've done similar things with JMock, not down to a page model, but standard repeatable elements are encapsulated in other objects, initializers, that are going to handle the specifics of the instance rather than rewriting that multiple times, or creating a base class or modifying a unit test on an individual basis. So here's our page object. If we look at the developer works page, you can see we just have a simple search. So we're coming into our search page, and one of the things that we need to do, because it's a web application, is handle the locations, URLs, things of that sort. In our production type library, we use the concept of a default. Everybody can set up a default in a configuration file, and it just goes to what you have set up in the configuration file. Something similar is displayed here, where I actually pass in the URL, but in our environment, we pass in the name of the environment we want to connect to. That name opens up into a configuration file that actually provides the URL for where we need to go to, depending upon what environment you're actually testing in. But very similar right here, where we get our driver, and a web driver is the programmatic representation of your web browser. If we look here, we can see I'm actually using a driver called HTML unit, which doesn't actually connect to an instance of any particular web browser. It uses Java and another library called HTML unit to programmatically browse, various websites. You give it a URL, it will go to that URL, it will download that page, and then parse the resulting HTML and allow you to manipulate it, use it just like you would if you were in a regular browser, but there is no actual web browser at this point. It's all done in memory. This works well for pages that do not involve much JavaScript, or the JavaScript is merely used for UI functionality, such as right-clicking, popping up menus. If you're going to a specific location based upon a URL and you're not trying to manipulate the mouse or any other UI elements to perform navigation, this driver works very well, and it's rather quick. So in other cases where you need a web browser per se, which we'll take a look there for the screenshot issue, you're going to require a different browser, be it Internet Explorer, which I think we're using in our example, or some other supported browser. But there are, for this library, I'm sure many other libraries.
Hey, Ken?
Yes.
Seeing that we do have light attendance today, I'm just going to open up the lines because it looks like Peter has a question there. And,
okay.
So I'm just going to go ahead and just open the lines. Give me a second here.
All participants are now in interactive talk mode.
And so Peter mentions here that so you decompose the test code according to the target UI. He's seen similar approaches using a decomposition by domain object, similar to the decomposition of the application, for example, bank account, user, and so on. Which considerations did you guide there? And Peter, I didn't know if you had any other further clarification of that or not, but.
So if I'm getting it correctly, the question is about what guided us to using the page object model?
Yes, exactly.
Okay. Well, in our case, obviously we had a web application, and part of the web application is the web pages that the user is going to see. The system integration test team that we have works purely on a page model. all of our pages are identified. They're testing based upon, that page object identifier. There's no, they're coming in, they're not testing the system, they're testing what the system does. So from our perspective, we wanted to mirror what they were doing to some extent so that we could run our tests to give them the quality that they were expecting. So from our perspective, breaking it down to a page was simple, and then taking the page as a model of, a unit of evaluation, we came up with, obviously not entirely by ourselves, we're out there doing research on the concept of page objects, and the page objects encapsulating various components of the page functionality. So that allowed us, we have, a provider subsystem. So we have a provider base that page object that provides some standard functionality from a menuing system on down, and then each individual page starts deriving from our provider-based subsystem in a, if you think about it, like I said, from a domain model, you're building an application, a lot of the same design process goes into that, as opposed, the testing of it is very similar. We're divided by subsystem, we're grouping common functionality, we're creating these classes. So now, we have a mature provider subsystem end-to-end regression framework test, and a developer can really, I don't want to say crank out, but he can write unit tests rather quickly now in that environment, because a lot of the functionality is covered by these page objects. So the actual unit test is testing the specific functionality rather than writing the code to get to a particular point in the test or move the browser to a particular location to do something. We as the environment matured, we got a lot of that. I don't want to say for free, but like I said, the provider environment that we have is the most mature. So, from our perspective, that's what drove that. Does that answer your question, or begin to answer your question?
Oh, thank you. That's a perfect answer. Yes.
Are there any other questions? Anybody? Okay, then we can go on to our final unit test, because this is the part that we use to do the documentation aspect of what we're looking to accomplish. And in this particular case, we're creating the developer works page, and then we're taking the screenshot. For our environment, the screenshot taking portion of the unit test or the end-to-end regression is the meat of the regression test. It is the documentation of what has been accomplished. So in this particular library, it's very easy to use a browser. In this case, you can see we're not using the HTML unit web driver, but in actuality, the Internet Explorer driver. And again, the HTML unit doesn't support taking a picture of anything. It's not rendering code. It is just passing code through memory. So we're using Internet Explorer here, and we'll go through and we take a screenshot of the particular page that we're on. In a scenario, this take screenshot is a method filled into our base fixture, which we use. You're going to need some sort of code mechanism to handle various aspects of the system. We have a particular one that's we call it a pen test package, and it takes more information and it produces that XML file. So you're going to have a test. The test is going to run, and you can picture multiple unit tests with multiple screenshots over time, and based upon where they're run, the location can change, and we have multiple screenshots of various functionality. And that functionality then gets coded into the XML file. The XML file gets produced, over through the FOP engine into the PDF, and that is the artifact that we're going to turn over to the SIT integration team to prove or demonstrate the functionality that we were going after. Again, the end-to-end regression is still a unit test. We still do various assertions in the test to make sure what we're looking for is there, is present, and the test itself runs fine. I mentioned before that we have, per project, 2 developers working on a project. One is developing the unit test for the code. The other is writing the end-to-end regression for the test package production. And by working together, it comes out nicely because the developer can run the end-to-end regression at any point to get a sense for what they're doing. They've proven via their unit tests, their J units, that their code is functioning properly. It is doing what is expected. By doing the end-to-end regression, whether it's run locally against a database that we maintain, or it's run in a development environment against a database that another team maintains, we need to have the ability to have the developer run their code against the end-to-end regression to demonstrate that what they have done is what is expected to be done. Now, again, I'll just revisit we write these as unit tests. They're not scripts. They're not, because our integration team uses a scripting product to accomplish a lot of the same thing. In our particular case, the Java developers were not as amenable to writing scripts in a third-party language to use in an environment that already existed. They felt much more comfortable actually writing a unit test in their rational environment that they use every day to perform other functions on the team. So there was just a natural fit there to keep everybody in code as opposed to jumping out into some sort of script type product. So we thought it gave us a much better feel for what we were doing. The only other thing that I have to say about our end-to-end regression is one of the things, the big problem that came up was in producing this type of documentation. People are used to a certain level of documentation in document form, Word, whether it's an Excel document. They wanted what they had been getting, and switching to this type of system where we're actually writing code to produce a document, and they're not going to get that document. The document itself can change over time without them expecting it because we're changing unit tests. Our unit tests change all the time depending upon projects, adding fields, removing fields, changing the way the functionality works. So getting them to buy in was a big portion of this project. The writing of the library to handle our specific instances was, I would say not trivial, but it was, an exercise in writing code. We knew what we needed to do, and we just needed to produce it. We added a handful of custom annotations that we use so that a developer doesn't have to rewrite various things. Because one of the things that we do is we produce a table of contents that we call our test package plan. So, we have developers writing the unit tests which map to specific items in the final produced document that demonstrate all of the intended functionality that they're going to test. The unit tests themselves, because they had been stubbed out to create this, to produce that document, kind of give us the guide for how long it's going to take to actually complete the actual regression test. You're writing a regression and it has 50 individual unit tests in it. It takes a minimum amount of time to get there for each unit test. You can just figure out how long it will take, as opposed to I'm going to create a document and we just it needs to be done by Friday, and just throw that out there as a number, and people have to meet that deadline and get through it. By having our unit tests pre-written, if you will, they're stubbed out. We know there's an expectation of X number, and people will approve based upon the unit tests coming in to produce that document. One of the things that we found, because it is a document, because developers are the people receiving the document are not developers, the first step that we took was our tests were the names of the actual elements in the document that was produced, and obviously that turned out not to be what we expected. So we moved on to producing a series of these annotations that would take text strings in them to produce what we'll call the proper readable documentation. So given a test like this, that you run it, you take a screenshot, you get an image, the image is placed in the PDF, and we have annotations to describe that in a more readable type fashion.
Okay. Just a short question.
Excuse me?
You said that you did not succeed using test names to create documentation names. And I see this being used in some BDD frameworks. So what were the issues there? Why didn't it work out?
Okay, so I had some trouble hearing, but the question, I believe, was, what issues with the data, using the annotations for the data?
No. You said you first used test names from the classes to produce also text in your documentation.
Oh, okay, yeah, so...
But it didn't work.
Right.
And I see this approach in several BDD frameworks. So the question is, what were the issues? Why didn't it work?
Okay. So initially, we would have the name of the class that was running the test that would kind of group the tests that you were getting. Because when we talk about a test package, we're saying we're running through a particular page. That page has various sets of functionality. So there'll be page 1 and 10 individual tests for that page. So our initial case was, well, we'll have a single test fixture with 10 tests in it to demonstrate that particularly worked. And we just simply mapped the fixture name to the unit test, to the final document. The actual unit test method would be a label for the diagram. And what didn't work was the names were extremely contrived and didn't make sense for what the test was, I don't want to say not doing, because it did express it, but we would produce that, give it to the other teams, and they would look at it and just say, I don't know what you're trying to do here. I see something called provider page validation fixture, and our initial plan was, well, what if we come up with a naming scheme which contradicts our JUnit naming scheme, but yet another scheme, and then we can start pulling out various components from there. And the final solution that we came upon was we have an interface that we call a test group, and the test group is involved in describing the actual test. The individual methods that we have an annotation on it, which takes some descriptive text. And then when we go into our base class to actually take a picture of the actual screen at that particular point in time, we then use the group, which is passed in, to get the, the names for, say, the table of contents. The group putting together gets a description, so we pull that all out from our testing group, and then the actual test description is in an annotation at that point, and we just use reflection to go through and figure out where we are, and we pull out that information. So the test document has a bigger or a more natural feel to it rather than just being a collection of class names and method names with pictures. So that was the solution we came up with. One of the big arguments against that was we are now recording we'll call test information, for the final documentation into the actual unit test. And after a lot of discussion, it was decided that that was okay with us because the end-to-end regression was not a reusable component. The end-to-end regression, while the page objects were reusable, we're not coding anything like that into them. The actual unit test was the code being annotated. So we would keep that in the unit test. The unit test would run and produce that documentation, but the limitation of having that coded there was okay for our case because, that is a specific test case for a specific thing, and these end-to-end regressions were for a specific purpose, producing that type of documentation. So we didn't pollute our page objects with any textual information. They're handling pure functionality, binding to elements on a page, and the actual unit tests themselves are the ones handling the code, but our end-to-end regressions are producing a document so we can live with having so-called documentation in our tests.
All right, Ken, we got about 7 minutes left, so I don't know how you want to wrap this up here.
Well, wrap it up. I think the big issue through this whole transition has been getting people used to using unit tests. I mean, we still have developers on the team who don't seem to find the time to write a unit test. And when asked, they'll say, well, I'm just so busy, I don't have time to do that. But not having a unit test on my project means you can't check your code in. It's not going to build. We're not going to push that anyplace. And continually getting people to be reminded of that is the big issue. So from a developer perspective, from an organization that has not traditionally been doing any unit tests, going to a scenario where you're writing unit tests for your program, you're writing end-to-end regressions, whether you're writing the code or not. And, each project we move around and swap roles, but getting people into that mindset that a test is the first-class citizen of your project is difficult. I mean, we still have phases of old code and new code. Last time we talked about refactoring for testability, and that's something we're doing now, but there's code out there that we have that is horribly untestable and kind of, we'll call it first phase made testable. So, even that needs to be revisited. And developers are not as keen on going back there if they're not in the test development mode. I will say from a management perspective that they are extremely excited to see this kind of work being done and producing these products in a, automated fashion is huge. I'm sure you can speak to that. I mean, IBM has, large swaths of products that do sorts of, just make the stuff repeatable. I don't want developers sitting around creating documentation, but if they can write code and demonstrate things, that's great. And that stuff is, pure gold from my perspective to keep developers writing code, but produce the types of, artifacts that management needs to demonstrate to the client that they're, doing a good job. It's all about the client, and you need to demonstrate the quality. You need to, have a good product in the end, and this gets us there. So it takes away the anecdotal evidence of things are getting better into some sort of proven model that we can just rerun at any point in time and let you know if we made it. So.
Cool. Do you want to flip over to, I think, the next slide there, or? Yeah. So I see you've mentioned some links there, and perhaps I misspoke a little bit on the Selenium stuff, but there were some recording tools that I had seen, and the rational functional tester, I don't know if you all use that kind in your environment, but when I think of end-to-end testing, I often think of running the application and driving it from the GUI, and then capturing either a function or functional test or performance test aligned with the, I don't know if you heard of the acronym FERPS, which is a way to test various requirements, FERPS being functionality, usability, reliability, performance, and supportability. And that FERPS approach can be backed by a couple of different rational tools, functional tester. That's kind of actually a nifty tool that I've used within the IBM work environment to work with existing systems to improve my productivity. There's one system in particular that I used previously that I had to enter in data for 17 of my employees, and it would take about half an hour to go through each employee's data and enter it in, and then go to the next screen and enter and put all the information in. And what I ended up doing is actually recorded a session going through one scenario with one employee, and then I varied the data using an input spreadsheet. And so took all the different data elements in the spreadsheet and then played that scenario back with functional tester, and it went through and entered in all the different data sets and all of those 17 employees in about 10 minutes. So instead of 17 employees times 30 minutes per employee, so 8 hours worth of time, I was able to automate that into about 10 minutes. That was kind of cool. And then there's some other good articles on designing SOA services and RESTful services with RSA based on some UML. So it's taking UML class diagrams and transferring them to WSDLs. There's a support for that in Rational Software Architect. And I just put a UML basics in there. There's a common theme that, gee, it would be nice to know, when I'm building any kind of test, unit test or a functional test, how is this actually going to get used from an application user standpoint? And the sequence diagram, which is something that oftentimes the designers of the application will build to confirm that this is how the functionality will flow with the user. Those can often be great sources of testing scripts as well. And so just kind of documenting that sequence diagram there is another wonderful colleague of mine, Donald Bell, who wrote that article, and is a good, helpful way to build some more collaboration from design all the way down to test. So, any closing thoughts here in the minute we have, or closing questions, Peter? Okay.
Just unit test everything. That's our
there's definitely an advantage, and I think probably a lot of teams have to make some trade-off decisions, but I think there's one place where you can definitely make an impact on the resulting timeline. Just a little work in the quality and verifying quality can have a bigger impact in the deliverable timeframes in the back end. So thank you, Ken. I appreciate your help today, and with that, I'll close the call.
Okay, thank you.